Okay, great. It looks like we are all ready. So, hello, everybody. Welcome to this very special Earth Week PORTScast. Before we jump right into our tide pool exploration, I just want to give a big congratulations to our logo contest winners. Thank you to every single person who submitted any of your gorgeous artwork, but an especially big congratulations to Zoe, who won. You can check out all of the beautiful logos or a couple of our first, second, and third place logos right here. But I think we are just about ready to dive right in. So, before we begin, I need everybody to get just a couple of things for me. So I'm going to be doing a lot of talking. You're going to be doing a lot of listening, and you may come up with some questions as we're going. And I'll have a couple of interactions where you may want to write down some of the answers to my questions. So to do that, you're going to need just a couple of things. You are going to need a piece of paper, and you are going to need a pencil or a pen or something else to write with. My name is Lily, and welcome to today's very special Earth Week PORTScast. Thank you all for joining me to celebrate our beautiful planet, and especially right now, we're going to be celebrating the underwater part of our planet. So let's dive right on in. So to start us out, let's start with where I am right now. So I am an interpreter for California State Parks, and today we are talking about Natural Bridges State Beach. Natural Bridges is in California in the Monterey Bay, kind of on the northern edge of the Monterey Bay. And if you're not really local, we're just a little bit south of San Francisco. This is a video of the beach at Natural Bridges State Beach. And you can see on it, there's a big old rock right in the middle of the ocean. In fact, I'm going to make myself a little bit bigger so I can point it out to you. Right there. That is the natural bridge that the park is named for. You can see there's this hole worn away in the middle of it that the ocean just wore away over years and years and years. And this is the only remaining natural bridge that we have at the park. But it's not the only one we've ever had. So you can see right here to here, there's a little rock in the middle of the ocean right there. There used to be another bridge that connected these two right here. And there was another one that went between the current bridge and the mainland. And a couple years ago, we had some pretty big storms. And so I'm going to zoom in right here and tell you a cool little story about what we found when those storms cleared. So these big old storms kind of tore up parts of our coast. But eventually, when things were nice and clear, when the sky was big and beautiful and it was safe to go back onto the beach, we found something really cool. We found this. This is a hole in the middle of the rock. So the ocean was so rough that it punched a hole through the middle of that rock, and it became it's becoming a second bridge. Right now, it's a small hole. It started about this big, about the size of a dinner plate. And over the past 2 years, it's gotten bigger and bigger and bigger. And now it's even big enough for people to crawl through. So it's wearing away fast, and eventually we are going to have a whole new natural bridge. So that is very exciting. But we're not here to talk about geology. We're here to talk about the ocean. So behind me, I have a video of the tide pools. How many of you have ever been to tide pools before? Do you know what a tide pool is? Do you know what you might find there? If you think you know what a tide pool is or you know some cool facts about it, why don't you go ahead and write it down on that piece of paper, or you can even tell someone who's sitting next to you. What is a tide pool? I'm sure you had some really good answers. A tide pool happens when the ocean wears away holes in the rocks, and those holes get filled with water, and all kinds of things can live in those little pools. So these here are some tide pools, but how exactly do they form? Well, let's take a look at this time-lapse video. So this is a time-lapse of a day at Natural Bridges. And you're going to see the ocean here, and it'll start speeding up. And I want you to make a guess. Is the ocean going to stay the same throughout our entire time-lapse? Or do you think it's going to change? Is it going to get higher? Is it going to get lower? What do you think is going to happen as we watch? So you can see there's this big tide pooling area here, and that gives you a good idea of where the ocean level started. And as the day goes on, that ocean level is changing and it is getting lower. So you can see a lot more of the rock now than you could have in the beginning of the video. And so this is what happens when the tides change. They start out high and then they get lower and then they go back to being high. And this happens every single day. In fact, twice a day, every single day. And now you can see that it's low tide. There's all kinds of people walking around out on the tide pool shelf, and they're doing what we're going to be doing virtually today. They're looking in all of the pools that are now exposed, and they're seeing all kinds of cool animals that live in them. So pretty neat. Now, when we are going through our tides today, we're going to be separating it into a couple of different sections, a couple of different zones. And you can see I've drawn the lines of our zones behind me on our tide pool shelf here. Now these zones, you can think of them as sort of like habitats. Do you know what a habitat is? A lot of us might be familiar with the word habitat, but not all of us will be. So if you think you know what a habitat is, you can go ahead and write it down on your piece of paper, or you can tell somebody next to you, what do you think a habitat is? Well, a habitat is just a place, any place, where things live. That's it. Pretty simple. But because it's got a simple definition, do you think that all habitats are the same? No, of course not. There are many different kinds of habitats, and the different habitats are changed based on the conditions of the place and what lives in it. Do you think a redwood forest habitat is going to have the same plants and animals that a desert habitat might have? No, they're going to be pretty different. And that's just like our tide pools here. So each one of these little zones back here is sort of like its own habitat. And they're going to change based on the different conditions. See, as the water raises and lowers, different areas of the tide pool shelf are going to be exposed to water and light and air and heat for different amounts of times in the day. And those differences make those zones very different habitats. So we're going to talk about a bunch of different ones. And here you can see them all labeled out for us. So starting farthest away from the ocean, we have the splash zone. Getting a little bit closer, the high tide zone. Stepping even closer to the ocean, the mid tide zone and the low tide zone, which is right at the ocean's edge. And then the subtidal zone is underwater all the time. So let's jump right on into our tide pools, and we're going to start farthest away from the ocean first. We're starting off in the splash zone. Now, behind me, you can see some photos of the splash zone tide pools. They look kind of rough, don't they? They look pretty shallow. It doesn't look like there's a whole lot of water. Maybe it's kind of warm there. So do you think that these are going to be a really easy place to live? No, they are not an easy place to live at all. In fact, they're kind of a tough place to live. But when you look at this tide pool here, would you say that you think it's lifeless? Would you say you think nothing lives in it? Well, how about I show you this video next, and then you can tell me what you think. All right. What do you think about this video? Let me turn up the quality a little bit so you can see it a little bit better. Take a look at this video. Do you think that there is nothing living in these splash zone tide pools? No, of course not. There's tons living in these splash zone tide pools. You can see all kinds of little animals zipping around inside the water there. So even though it's a hard place to live, there's still plenty that lives here. So the biggest challenge for these splash zone tide pools is water loss. Like I mentioned before, they can get pretty warm and a lot of that water can evaporate away. So the animals that live in the splash zone have to be really well adapted to keeping water inside their bodies. Now, hold on. What was that word that I just used? I said the word adapted or adaptation. Now, when you hear that word, do you know what that means? Go ahead and write down if you think you know what an adaptation is, or you can tell somebody next to you, what do you think the word adapted means? What is an adaptation? I'm sure you all had some really great answers. An adaptation is the way that an animal's body or a plant has changed over a long, long time, over generations and generations, to best suit its environment. So, one good example of an adaptation is ducks have webbing between their feet. And that webbing helps them swim a lot better than not having the webbing does. Well, our animals that live in the tide pools are all adapted to very different circumstances, but in the splash zone, our animals in particular have a lot of good adaptations against losing water. So let's meet a couple of our splash zone animals here. Starting off right here above me, we have barnacles. Next to them, we've got limpets on the other end. We have snails here. And all the way on the other end, we have copepods. So let's talk about each one of them a little bit individually. Starting out with our adorable little periwinkle snails, I want you to take your pinky finger and look at your pinky fingernail. And I want you to imagine in your brain that you're dividing it into 4 sections. That's about the size of a periwinkle snail. They're very, very little, which means they lose water. They could lose water really easily, but they don't. They have this cool adaptation called an operculum, which is spelled over here. And that operculum is sort of like a front door to their shell. They can close it up and hold all of that water inside their shell. So periwinkle snails, they've got that operculum, a coiled shell like this and a trap door in the front to keep predators out and to hold water in. Moving right along, next we have our rough limpet. Now it's called a rough limpet because as you can see on this picture over here, they have a pretty spiky outline on the outside of their body. And those rough limpets are sort of similar to snails in that they have a really soft, squishy foot underneath them, and that foot can suction down onto the rocks. And in fact, those limpets suction down onto the rocks so hard that they create a little scar on the rock. That little scar is called a home scar, and the limpet comes back to it every single day. And it's the perfect outline of its body, so it seals itself in and it's able to prevent itself from losing water from its body. So rough limpets and limpets in general use really strong suction. Next we have, not quite yet. We'll get to these guys in a second. Next, we have the acorn barnacle. Acorn barnacles are a super cool animal here. You can see we have a bunch of different looks of our acorn barnacles here. This right here is one barnacle. You can see it's got this hard outer shell and it's got this part in the middle that sort of looks like a beak like this. It's closed. But I also see some of them that don't have a beak in them. What do you think is going on with those? You can discuss with a neighbor or write on your piece of paper. What do you think is going on with some of these pieces here that don't seem like they have any beaks in them, something like right here. What's going on there? It's a little bit of a mystery, isn't it? Well, what's going on with these empty acorn barnacle shells is there are no longer living barnacles living in there. The ones that have a little beak like this, those do still have an alive barnacle in them, but the ones that don't have any kind of beak like this guy right here, there used to be an alive barnacle in it, but there is no longer, and their shell is still stuck on there. So that beak right there, this here, is how they keep their water in. They close that little beak, and then they can keep all the water inside of their hard shell. Now we can get to one of my favorite tide pool animals and probably my favorite splash zone animal. This guy is called a copepod. Now, copepods are kind of like tide pool superheroes. They can survive almost anything. So here's what we're going to do. We're going to play a little game. And in this game, I'm going to give you a scenario for our splash zone tide pool. We're going to talk about different conditions that you might have to survive living in a splash zone tide pool. And after each one, we're going to say together, copepods survive it all. Okay? And this is true. Every scenario that I'm about to tell you, copepods really can survive. So let's start with just a beautiful sunny day, but not too warm, not too cold, the most perfect splash zone tide pool imaginable. Copepods survive it all. But that one's pretty easy. Let's take it a little bit tougher. What if it gets kind of warm and some water starts evaporating from our tide pool? And because the water is evaporating out, we have salt left inside of our pool. Well, what happens? Copepods survive it all. Now, how about if it rains and all of a sudden we got all this fresh water running right into our pool? And then all of a sudden it's way less salty than we're used to it. Copepods survive it all. How about if the sun comes back and our pool gets really, really warm, like really warm? Copepods survive it all. How about if it gets so warm that our pool dries out completely? Copepods survive it all. And how about one final change? What if our pool all of a sudden gets splashed by a big old wave and all of a sudden it's really, really cold? Copepods survive it all. So these copepods are kind of like our tide pool superheroes. They really can survive drying out. They can survive near freezing temperatures. They can survive when it's really hot. So they're really well adapted to living in this harsh environment. Now let's take a couple steps closer to the ocean here into the high tide zone. The high tide zone here, it's going to be a little bit less dry than our splash zone tide pools. It's probably still going to be pretty warm. But what do you think is different about these ones? Take a look at the picture behind me. And what changes do you see between our splash zone tide pool picture and this one here? Go ahead and write something down or tell a neighbor what's different between these zones. Well, for one, we're closer to the ocean. And being a little bit closer to the ocean means we have a little bit more water in the high tide zone here. And you can see in this picture behind me, there's definitely more water than in the picture of our splash zone tide pool. You can see all these little trails in here from all kinds of snails that we'll talk about in a little bit. And the biggest challenge in the high tide zone, still water loss. Water loss is still a really important part of the high tide zone life. But these animals need to protect themselves from the sun. They get a lot of sun exposure and these pools are pretty shallow, so there aren't that many places to hide. So let's meet some of our animals and figure out how they're adapted to water loss and sun protection. Here are three of our animals here. Starting right here, we have anemones, a sea anemone. We have some lined shore crabs. And we have on the other end there some black turban snails. Let's start out with our friend the anemone here. Now, this is an anemone right behind me. And all the way on the other end, that's also an anemone. But these pictures look pretty different, don't they? Go ahead and either write it down or tell a neighbor what is going on in these photos. What do you think the difference is? What's happening here? Well, one big difference is how these animals are adapting to the sun. So something that I notice is that in this picture, it looks like this anemone is not underwater. But in the other picture on the end over here, the anemone is underwater. So this anemone here has curled its body up. And that curling motion does help prevent it from losing water. Whereas these ones that are underwater over here, they're pretty happy. So they have their bodies out and open like this. All their tentacles are out. There's another thing, though, that this anemone right behind me is doing to protect itself from losing water and to protect itself from the sun. And that has to do with all these little bits of sand and shells that are along the outside of its body. Now, those aren't there by accident. It's not like a big wave washed up and then it just kind of dumped a bunch of shells all over our poor anemone. Our anemone has those shells attached to it on purpose. It uses them like a shield. It's covering itself in all kinds of shells and sand, and it's using it kind of like a sunblock. So it's preventing itself from losing water, and it's keeping the sun off of its body at the same time. So that's pretty cool. Now, here's our friend the black turban snails. These are the guys who are making all those cute little trails in that picture we were looking at earlier. And these black turban snails have a very similar adaptation that our periwinkle snails did earlier. Black turban snails are a lot bigger. They're about the size of my thumbnail here. And these guys also have that same thing that the periwinkle snails have. Do you remember what it's called? You have a coiled shell and a front door, and that front door is called an operculum. So our black turban snails also have an operculum, and they can close that front door and prevent themselves from losing water. Now, our line shore crabs are super cool animals here. What do you think is going on with this crab right here? What do you think's happening? What do you notice? What do you wonder? You can go ahead and write it down on your piece of paper. You can tell somebody next to you what is going on with this crab here. This crab is covered in bubbles. But why is it covered in bubbles? Well, I'll tell you what, it's not sea foam. That crab made those bubbles. One of the ways that the crabs survive drying out is they blow bubbles with their gills. Crabs have really hard shells on their backs, so if their shell dries out, that's okay. But they breathe through very sensitive gills. And if those gills dry out, that crab is going to have a pretty bad time. So they've got to keep those gills wet. And the way they keep those gills wet is by blowing bubbles, and by covering those gills in the bubbles, they stay moist enough for them to walk around outside of the water. A lot of our tide pool animals need to either stay in the water or they need to stay really, really in the same spot when they're out of the water and just kind of wait it out. But our crabs, they can move around. And while they're moving around between the different pools, they can blow bubbles to keep their gills nice and moist. Now, we're going to take even more steps towards the ocean here, and we are going to the mid-tide zone. This picture, to me, looks pretty different from the last two zones that we've talked about. What do you notice that's different about the mid-tide zone picture here? Go ahead and write some things down or tell someone next to you, what do you notice that's different? There are a lot of different things that are pretty different from this picture here, right? One of the first things that I notice is that this pool looks like it has a lot more water in it. It looks like there's a lot more water in it. It's a much deeper pool. And I see a lot more different kinds of animals in our photo here. I see all kinds of mussels on the outside. I see some anemones inside. It just looks like a lot more like an ocean habitat that I would think about. So here in the mid-tide zone, we have a lot more water, so we don't have to worry as much about losing water. We don't have to worry as much about sun because the mid-tide zone pools are a bit deeper. But we do have to worry about rough waves. How many of you have ever been to the beach and you're looking at the ocean, you're standing next to the waves, and all of a sudden a really big wave comes and it knocks you right over? That's happened to me for sure. Well, that is what our tide pool animals have to deal with all the time. They live there on the edge of the ocean. So they're constantly having to deal with rough waves coming and trying to knock them off of the rocks. So our animals that are in the mid-tide zone are very well adapted to clinging to the rocks super well. Here are a couple of the animals that we'll meet in the mid-tide zone. In particular, we're coming back to our friend the anemone here. We're also going to be talking about mussels and owl limpets. So right behind me here, we have what's called a sunburst anemone. It's called a sunburst anemone because it's got all these beautiful stripes all over the inside of its body here. And our anemones are very well adapted to sticking to the rocks. And they use a giant suction cup on the bottom of their body. Like this, they suction down onto the rocks and they secrete just a little bit of glue, and that holds them onto the rocks really, really well. Now, here we have some more barnacles. Now, think back to what we talked about earlier with the barnacles. The barnacles that had a beak like this were alive barnacles. And the barnacles that had holes in them did not have an alive barnacle anymore. So what do we think about these barnacles right here? Are these alive barnacles? Or are these not alive barnacles? These guys are not alive barnacles. So these guys here, they used to have an alive barnacle there. Some barnacles settled, made its nice little shell there, and then it lived its life and it died. But those shells are still left on this piece of wood or this rock. They're still left there, even when the animal isn't there anymore. Those barnacles, when they settle down onto a rock or a piece of wood or a piece of bone, they settle there for good. They don't get up and move ever again. And to settle there completely, they use a super, super strong glue. And then they permanently cement themselves onto that spot. So even when there's no more alive barnacle in there, you can still have the barnacle casing on the outside. So they're really good at sticking to those rocks. Now, another cool animal that we've got here, these are called California mussels. Now, not mussels like super strong mussels, mussels like mussel. They are called a bivalve. Bi means two, valve means shells. They've got two shells like this. And that's a little bit hard to tell from the angle that we're looking at right now. But these mussels have two shells, and it's secreting something onto the rock here. What do you think is going on with this mussel? Go ahead and write down on your piece of paper or tell somebody next to you what is going on with this mussel. well, there's all these threads coming out of it. So these little threads are sort of like Spider-Man's webs. They can shoot out that byssal thread and stick it to the rock, and then they hold on to the other end. And just one thread isn't super strong. But if they put out 5, 10, 20 threads, then they can hold on to the rock really, really well. And these are called byssal threads. Again, spelled right here above me, Byssal. And the good thing about the byssal threads is our muscle knows how to regrow them. So if our muscle gets knocked off the rocks, well, if they find another good spot, they can just put some more byssal threads out and they can stick a little bit better. Now, one more super cool animal in the mid-tide zone, one of my personal favorites. This is an owl limpet. Now, we learned a little bit about the rough limpet earlier today. It had those spiky outlines like that. And our owl limpet has a much smoother outline. But our owl limpets, they use the same way that the rough limpet did. They use a squishy foot to suction down onto the rock super well. Our owl limpets have a super cool life history. They're pretty big. They can be about this big. And our owl limpets are farmers. Now, you tell me, or you can write down on your piece of paper, or you can tell someone next to you, what do you notice about this picture behind me? I sort of gave you a little bit of a hint. But what do you notice about this picture here? Well, there are many, many, many things you could notice, but something that I notice is that we've got our owl limpet right in the middle over there, but we don't have a whole lot else right next to it. I'm also noticing that if you look pretty closely on this picture, there's all these little scrape marks all over the rocks. Well, that's because, like I mentioned, our owl limpet is a farm. It's not out in our fields growing beautiful carrots and Brussels sprouts and artichokes. Our owl limpet is growing algae for itself to eat. And those little scrape marks are where our owl limpet has scraped the algae off the rocks to eat. There aren't a whole lot of other animals living real close to our owl limpet because our owl limpet kicks them off. It says, hey, this is my farmland here. And so you need to scooch away. So it's protecting its little area. Another super cool thing about the owl limpet is all the ones that are farmers and big like this, they're all ladies. They're all female owl limpets. All owl limpets actually start off as male in the beginning of their life. Then once they get big enough, they all turn female and then they become farmers like this. So I think that is pretty neat. Now, let's take some steps even closer to the ocean here. We are going to the low tide zone. This picture looks way different than anything else that we've seen today. What do you notice about the picture behind me? You can write some things down or you can tell someone next to me. What do you notice about the low tide zone? Well, there's a lot to notice about the low tide zone, that's for sure. Something that I notice is it is right on the edge of the ocean. At some point, those low tide zone pools just sort of exist in the ocean and they're not on the land anymore. I'm also noticing that these pools look a lot bigger and a lot deeper than anything that we've seen before. So we're right up on the ocean's edge here. The biggest challenge for the low tide zone is that there's not enough space. When you're in the low tide zone, you don't really have to worry too much about water because you're right next to the ocean, so you're underwater most of the time. You don't have to worry too much about the sun or heat because all the sun and the heat is being dispersed by the much more water that you have, the much deeper pools. So because it's such a great condition, everything wants to live there. And if everything wants to live there, it gets really crowded. But there's one more problem in the low tide zone: predators. Now, if all of our animals are living in the low tide zone, that's probably also the best place to get a meal if you're a predator like a seagull here. So our low tide zone animals, they don't have it all perfect. They really need to compete for space and they need to protect themselves from predators. So let's meet a couple of our animals. Living in our low tide zone, we have some sea stars here, particularly our beautiful ochre sea star. We have a sea urchin up at the top over here, and a sea anemone down on the end here. We've met our sea anemone friend a couple times, but they live in a lot of different zones. Let's start out with our friend, the sea star here. So what is going on the underside of the sea star here? If your sea star normally walks along the ocean floor like this, we are looking at the bottom side of it. We're looking at the side that would be walking on the floor. So what do you think we're looking at right now? What's going on? Well, I'm seeing all these little things here that kind of look like, to me, they look like macaroni noodles. But they're not macaroni noodles, they are feet. Sea stars have tube feet. They use water pressure to move those little feet around, and that helps them move across the ocean floor. So if our sea star comes across a predator, it can just sort of move out of the way. But it doesn't move super fast. So it needs to have another way to protect itself. And that comes to the second thing that I notice about this picture. And you might have noticed it too already. I'm noticing that it looks pretty rough. It looks kind of spiky. It doesn't look like it'd be very comfortable to eat. Our sea stars have all kinds of bumps and spikes all over them so that they're not super easy and tasty for predators to eat. So that's how they protect themselves. They can move out of the way, and they've got all kinds of spikes so that they're not an easy meal. Speaking of not an easy meal, let's meet our friend here, the purple sea urchin. What do you notice about our purple sea urchin here? What kind of adaptations do you think it might have to protect itself from predators? I'm sure a lot of you are noticing those big purple spines. Those big purple spines are definitely its number one way to protect itself from predators. If you are a seagull or another animal that wants to eat it, in order to get to the meat of the urchin, you got to get through all of those spines. So they are well protected against predators. There's something else about this urchin too, though, that I'm noticing. It kind of looked like it's in a hole in the rock. In fact, it looks like it's in a sort of perfectly shaped hole. That hole looks like it's exactly meant to fit that sea urchin and no other urchins. Well, that's because that urchin made that hole. The sea urchin can wiggle away, wear away the rock just a little bit to make a nice little hole for itself, which means that if it's in a little hole, it's a lot more protected, even more protected. So if something wants to eat it, it can only come from the top side where the most spikes are. But this is kind of a double-edged sword. This is both good and bad. It's very well protected from predators because it's inside of the hole, and so it's really hard to get to. But if that urchin isn't careful, it can actually get stuck in that hole. If its body gets too big for the opening to that hole, it's stuck in there forever. And it just has to hope that some delicious algae is going to wash right over it for it to catch and eat, because it can't leave. So it's a good strategy, but those urchins have to watch out and make sure that they're not accidentally locking themselves inside of their own house. Our giant green anemone. Now, earlier we had a sunburst anemone that we were looking at, and there was something that I pointed out that let me know that it was a sunburst anemone. You might remember it in your brain, you might not, and that's okay. the thing I was looking for in our sunburst anemone was here to here, between the mouth and the tentacles, there were a ton of stripes. But on our giant green anemone, do we have those same stripes? No, we don't. So that's how I can know this right here is a giant green anemone because it doesn't have any stripes in the middle. And our big old sunburst anemone does have a bunch of stripes. Both our giant green anemone and our sunburst anemone use the same strategy to protect themselves from predators. And that is that they sting. Inside each of these little tentacles right here, they have stinging cells called nematocysts, which is a really big word. It's spelled out right there with the N. Those are nematocysts, and they work sort of like a coiled up little harpoon inside the cell. And when something brushes over that cell, it shoots that harpoon out. And when it shoots that harpoon out, it has a chemical on it that paralyzes the thing that touched it. Now, some of you might be thinking to yourself, hold on, Lily, slow down. I've touched an anemone before at an aquarium and it didn't sting me. What are you talking about? Well, luckily, us humans, our skin is too strong for our anemones to sting us. So if you're in an aquarium or somewhere that's okay to touch the animals, then if you touch them with your hand, you won't feel any stings. But let's say you're a tiny little fish or a really small snail. You would definitely be feeling that sting. That nematocyst, the harpoon, shoots out, stings that little fish, and paralyzes it. And then the anemone can take its prey back to its mouth and eat it. And that's the same way that it protects itself from predators. If there was something trying to eat it, well, they might get stung by those nematocysts. So our anemone is pretty good at protecting itself. Now, let's jump into our final zone here. We're going to put on our bathing suits or our wetsuits if you're here in Monterey because it's cold. And maybe you're going to put on a scuba mask and maybe you're going to have a little snorkel. And we're going to dive into the subtidal zone. Now, subtidal, what does that word mean? Well, it's made up of two different parts, sub and tidal. Sub means under, tidal means ocean waters. So it is under the ocean waters. The subtidal zone is always underwater. Our tide pool zones are out of the water sometimes, but our subtidal zone is never out of the water. So your classic subtidal zone ecosystems or habitats are things like kelp forests, coral reefs, the open ocean. So can you think of any subtidal zone animals? Maybe you have a favorite subtidal zone animal. Go ahead and tell somebody next to you or write it down on a piece of paper. What is your favorite subtidal zone animal? I'm sure it might be hard for you to pick. Or maybe you're like, no, I know exactly what my favorite animal is. For me, it's hard to pick because we've got so many fantastic animals. But some especially fun ones are things like whales, otters. I'm a big fan of the mola mola. There's all kinds of real cool subtidal animals out there. And now, the subtidal zone's biggest challenge is people. Remember, they're always underwater, so they don't ever have to worry about drying out. They don't have to worry about getting too warm because the ocean water keeps them cool. They don't have to worry about too much salt or too much sun. The biggest challenge is people. People can cause a lot of harm accidentally, but we need to work with the ocean, right? So we have marine protected areas. Now that's kind of a big phrase here. So let's break it down into those three words. Marine protected area. Marine, let's start with marine. What does the word marine mean? What do you think? The word marine means ocean. How protected? What do you do with something that you want to protect? What is a protected thing? Well, protecting something is keeping it safe. And how about area, our final word? What's an area? It's a place. It can be any place. So our marine protected areas are ocean places that we guard from harm. And that is what we have right here at Natural Bridges. We have our very own marine protected area where there is no fishing or collecting of any kind allowed. And similar to our low tide zone area, when you protect a place and you make sure that there aren't outside things coming to harm it, it gets really crowded. And when it gets super crowded in our marine protected area, well, some of those animals and plants, they have to move outside the marine protected area. And when they move outside the marine protected area, some of them might be caught by a fisherman. So our marine protected areas ensure that the animals inside that protected zone are happy, they can live their lives, and they won't get fished. But it also benefits the fishermen because it means that they're always going to have animals to catch and have their livelihood with. So it benefits the animals and it benefits the fishermen. Here at Natural Bridges, we have one special marine protected area called the Natural Bridges Intertidal State Marine Reserve, which is a long string of words that means this area here that's in red, it goes from Natural Bridges State Beach all the way up through Wilder Ranch State Park. And it in particular protects the tide pools or the intertidal zone. So our tide pool animals here are really well protected against any kind of fishing or collecting so that they can thrive. Now, how can you help protect our tide pool animals? Well, if you come and visit the tide pools, that can be here at Natural Bridges, or that can be anywhere that you find tide pools. There are a couple of general rules that will help you make sure our animals are really happy. So the very first rule is please don't take anything home with you. Everything that we take home, every shell, every rock, anything that you take home with you is something that an animal can't use. Maybe that shell that you just took home was going to be a home for a hermit crab. Or maybe that rock that you grabbed, some little critter was hiding underneath it. So please don't take anything home. In fact, rule number 2 is don't even pick it up. In some places, it's okay for you to very gently touch an animal with the same pressure that you would touch your eyelid with. Very, very soft, right? Your eye is really sensitive. You're not going to hurt your eye, so you're not using a lot of pressure if you touch your eye. Same with our tide pool animals. It's better for you, or it's better for the animals if you don't touch them at all. But if you just can't resist, touch really, really gently. And definitely don't pick any of them up. And don't move them around. Let's say you find a cool hermit crab and you pick it up and you're like, wow, I love this hermit crab. It's so cool. And then you just put it down in another pool. Well, there are a lot of animals that are very specific to the pool that they're living in. They have looked around the tide pool shelf and they've said, that one, that's going to be my home. And if you pick it up out of its home and just put it in another pool, now that animal has to either figure out how it's going to live in that pool or it's got to try to find its way back to its own home. So don't take anything home, but even more, don't even pick up our animals. Please also walk very gently. There are a lot of animals out there that cannot stand being stepped on by people. And even if some of them are strong enough that they could hold a person's weight, it's definitely not comfortable and it can put them on a lot of stress. So please try to walk on only bare rocks and not over our animals. And finally, please don't turn over rocks. Remember earlier when I mentioned if you take a rock home, maybe something was living underneath it? Well, the same for even just picking up and turning over rocks. If you pick it up and turn it over, there could have been something underneath it that was using that for cover. And now that poor little animal is out in the open. So mostly use your eyes. Try not to use your hands at all when you're wandering around the tide pools. And definitely don't take anything home with you. Thank you so much for learning about our marine protected areas with me. I have another small activity if you feel like sticking around. We're going to get to do some nature journaling in a second here, and we'll have time for questions. You can use the Q&A function. But first, I wanted to let you know where you can reach me if you have questions that you can't get answered right now. Maybe you have to leave early. Maybe you're feeling a little bit shy. That is A-okay. Go ahead and email me right here. Email Lily at naturalbridges@ports-ca.us and send me your questions if you're not able to ask them right now. If I have a lot of questions, I might not be able to get to every question. I will do my very best. But if I can't answer it, go ahead and send it to me right here. Now, hope everybody's got this written down because I'm going to be turning on our Tidepool background here. So I'm going to mute myself. I'm going to step out of the way for, let's say, 5 minutes, and you're going to have a little bit of time to look at this background here and go ahead and sketch down some of the cool animals that you see, or maybe you want to write down some questions that you feel like asking me later. But go ahead, enjoy this background for a little bit, and I will see you in 5 minutes. All righty, my friends. That was just about 5 minutes. So now I'm going to get just a little bit to our questions here. Let's see. I don't see a lot of questions here. I do see some folks were answering some of the questions, so great job. But I don't see any questions. Does anybody have any questions for me? No questions for me? None at all? All righty. Well then, my friends, thank you so much for joining us today. I hope that you enjoyed our little foray into the tide pools today. I also hope you are enjoying a beautiful Earth Week. Thank you all so much for joining me today. And I hope to see you in a California State Park real soon.